There is a sealed metal tube sitting on Mars right now. It has been sitting there for over a year. Nobody lost it. Nobody forgot about it. It is exactly where it is supposed to be, locked inside a rover in a crater on another planet, approximately 225 million kilometers from where you are right now. The tube is about the size of a cigar. It weighs almost nothing. It costs billions of dollars to put it there. And it might contain the answer to the oldest question humanity has ever asked. Nobody is going to get it. Not anytime soon, maybe not in your lifetime. And the reason why, the actual, documented, on-the-record reason, why the most potentially significant scientific sample in human history is sitting up there waiting, that is what nobody is talking about. That is the part that somehow disappeared from every front page within 48 hours of being announced by the actual head of NASA on live television, with peer-reviewed science behind it. And then the world moved on. The news cycle turned, and a question that has haunted every human civilization that ever looked up at the night sky just got quietly filed away under things people almost knew. So, let's go back. Not the beginning of this mission. The real beginning. 4 billion years ago. 4 billion years ago, Mars was not the dead, frozen, radiation-blasted wasteland it is today. It had water. Not traces, not underground ice. Real, standing surface water, rivers that carved channels into ancient rock, lakes that sat still enough for sediment to slowly settle to the bottom over millions of years. Scientists have known this for decades from orbital imagery and mineral data. But what Perseverance confirmed after landing in February 2021 is that Jezero Crater, a bowl-shaped depression just north of the Martian equator, roughly 28 miles wide, was once home to one of those lakes, not a puddle. A lake that grew as wide as 35 kilometers and as deep as 30 meters at its peak. Fed by a river system that carved inlet channels into the crater rim, filled it slowly, and eventually overflowed through an outlet on the other side. A lake that researchers believe persisted for millions of years. Long enough, stable enough, that on Earth a lake like this would have been full of life. Jezero Crater was chosen as the landing site for Perseverance from 60 candidate locations, specifically because of this. Ken Farley, Perseverance's project scientist from Caltech, has said that delta rocks, the sedimentary formations that built up where the ancient river met the ancient lake, are a great environment for entombing signs of ancient life as fossils in the geologic record. The entire mission was built around the idea that if microbial life ever existed on Mars, the sediments of a former lake delta would be the most likely place to find its fingerprints preserved. The rover spent 3 years slowly drilling and sampling across Jezero's floor and delta. It found igneous rock from ancient volcanic activity, sandstones signaling the earliest rivers, salt-rich mudstones from the shallow lake's evaporating edges. It pieced together, layer by layer, the geological biography of a place that no longer exists, a lake on a planet that turned cold and dry and merciless somewhere around 3 billion years ago, and has stayed that way ever since. Then Perseverance drove into the ancient river valley that once fed this lake, and it found the rock, July 18, 2024. The rover is moving through Neretva Vallis, the dried-out river channel that once carried water from higher ground down into Jezero's lake. It is now a rocky, wind-swept valley, nothing moving, nothing alive, the surface temperature swinging between -80 and +20 degrees Celsius depending on the time of day. The sky above is a pale butterscotch color. Radiation levels at the surface would be lethal to an unprotected human within months. Perseverance rolls up to a rock along the edge of a geological formation called Bright Angel, and the scientists watching the data feeds back on Earth go quiet. The rock is arrowhead-shaped, reddish-brown, as nearly everything on Mars is. Roughly 3 feet long and 2 feet wide. Not impressive at first glance, not the kind of thing you would stop to photograph on a hiking trail. But covering its surface, visible in the rover's cameras before any instruments were even deployed, were patterns. Leopard spots, lighter patches, each surrounded by a dark ring, scattered across the face of the rock in irregular clusters. Smaller ones scattered between them, poppy seeds they called them, tiny dark flecks concentrated in the same zones as the larger spots. Together the pattern looked like something something familiar. One mission scientist described the rock immediately as the most puzzling, complex, and potentially important thing the rover had encountered in 3 years of exploration. That description was not released publicly. The team said nothing to the press. Because on Earth, and this is the part that made those scientists quiet, when a geologist finds this specific pattern in an ancient mudstone from a watery environment, they already know what made it. They do not wonder. Leopard spots in iron-rich sedimentary rock from a formerly wet environment have one dominant explanation in Earth geology. They are the chemical residue of microbial activity, the fingerprint of bacteria that once fed on the minerals in the rock, converting them through metabolic chemistry, and left these specific spatial patterns behind as evidence that something living was once there. 3 days after finding the rock, Perseverance drilled into it. The sample, Tube 22, later named Sapphire Canyon, was sealed and stored in the rover's cache. No announcement, no press statement, no hint to the public, because the science team had to make absolutely sure. And making absolutely sure was going to take a year. What happened next is not what most people would expect. They did not rush to announce. They did the opposite. For 12 full months, a team led by Joel Horowitz, Associate Professor of Geosciences at Stony Brook University and Deputy Principal Investigator of the rover's PIXL instrument, specifically spent their time attempting to disprove what the data was showing them. 12 months. 1 entire year, trying to find a better explanation. PIXL, Planetary Instrument for X-ray Lithochemistry, sits at the end of Perseverance's robotic arm and produces detailed mineral maps of rock surfaces at resolutions far finer than the human eye could distinguish. It maps not just what minerals are present, but where they are relative to each other at the scale of individual grains. It was designed specifically to detect biosignature-relevant mineral patterns. What PIXL found inside those leopard spots was not vague. 2 minerals: vivianite, hydrated iron phosphate, and greigite, iron sulfide, appearing together. In close spatial association with organic carbon, the carbon-based molecules that form the chemical backbone of every living thing on Earth. All of it concentrated in these pattern zones, in a rock from an ancient mudstone environment, from a place where water once sat quietly for millions of years. On Earth, vivianite is found in peat bogs, in swamp sediments, in lake bottoms rich with decaying organic matter, environments where bacteria thrive by processing iron compounds for energy. Greigite is directly produced by certain categories of sulfur-reducing bacteria as a metabolic byproduct. Not occasionally, consistently, as part of their basic chemistry of staying alive. Joel Horowitz described the chemical logic of what they were seeing. The organic carbon in the rock appears to have reacted through a chain of sulfate chemistry step by step, converting mineral phases in a cascading sequence. In his own words, it is almost like a ladder of redox reactions taking place. A sequence, organized, progressive. The kind of chemical logic that on Earth is associated not with random abiotic processes, but with metabolic chains, with things that were alive and hungry and working. They tried every alternative explanation. High-temperature formation, minerals can sometimes form abiotically under intense heat, did not fit the data. Acidic reaction environments did not account for the spatial patterns. Shock events from ancient impacts could not explain the organic carbon association. 12 months of the world's best Mars scientists constructing every possible non-biological explanation for what Perseverance found, none of them worked. Not a single proposed mechanism fully accounted for the complete picture. The mineral identities, the spatial relationships, the organic carbon, the redox chemistry sequence, all of it together in a mudstone from an ancient lake environment. That is when NASA scheduled the press conference. September 10, 2025. NASA's acting administrator Sean Duffy stood at a podium and said something that no sitting head of NASA had ever said before. Not in this way, not with this level of peer-reviewed scientific support behind it. After a year of review, they have come back and said, listen, we can't find another explanation. So this very well could be the clearest sign of life that we've ever found on Mars, which is incredibly exciting. Sit with that for a second. The head of NASA, on the record. We can't find another explanation. That same day, the journal Nature published the peer-reviewed paper behind the announcement, led by Joel Hurwitz, confirming the findings had survived the full scrutiny of independent scientists with no stake in the result. Nature is not a tabloid. It is not a press release platform. It is arguably the most rigorous scientific journal on Earth, and outside experts who examined the data could not find a better explanation either. Nikki Fox, Associate Administrator for NASA's Science Mission Directorate, said it plainly at the same conference. The leopard spots are potentially made by some form of ancient life. It is a signature, she said. A sort of leftover sign. A leftover sign from something that was alive billions of years ago on Mars. And then there was a second paper published in Science Advances, co-led by Ashley Murphy of the Planetary Science Institute. Her team used a completely different instrument, Shearlock, which uses an ultraviolet laser to map organic molecules across rock surfaces to independently confirm organic carbon in the same bright angel formation. It made hundreds of detections across multiple mudstones. Hundreds. Murphy called it one of the most exciting findings to date and described it as a resounding win for Mars science. Two separate instruments, two separate research teams. Two journals, both pointing at the same geological formation. Both finding chemistry that belongs in a biology textbook. On social media, posts about the announcement racked up over 5 million views within days. People were briefly electrified. NASA found something. NASA said they could not find another explanation. NASA called it the clearest sign of life ever found on Mars. And then, within 48 hours, the story had largely vanished from the front pages. Other things happened. Other news arrived. The information avalanche buried it under everything else. The most significant potential discovery in the history of planetary science became yesterday's story before most people had a chance to fully absorb what had been said. And if that were the whole story, that would already be worth examining. But it is not the whole story, and this is the part that 2 days of coverage somehow never got to. The instruments on Perseverance cannot answer the question. They were never designed to. Pixel can map minerals, Shearlock can detect organics. But confirming whether those minerals were made by microbes or by abiotic chemistry requires equipment that is the size of a room. Mass spectrometers, electron microscopes, isotopic analysis tools that can distinguish biological carbon from geological carbon by examining the specific ratios of carbon isotopes inside it. Ratios that living things alter through their metabolic processes in ways that non-living chemistry does not. None of that equipment exists on Mars. The power requirements alone are prohibitive. The Sapphire Canyon sample has to come home. This was always the plan. Mars Sample Return, a joint mission between NASA and the European Space Agency, 20 years in development, was built to do exactly this. Send a follow-up mission to Mars, retrieve the cached samples, launch them off the Martian surface, and bring them back to Earth for laboratory analysis. Perseverance spent 3 years collecting samples specifically, so this mission would have material to retrieve. The rover was always only Phase 1. Bethany Ehlmann, planetary scientist at the University of Colorado Boulder, said it directly. A rock with a potential biosignature is awaiting return now, and other rocks hold breakthrough discoveries. The Planetary Society described the Chiava Falls sample as potentially the most valuable object in the solar system. The most valuable object in the solar system. Sealed in Tube 22. Waiting for Phase 2. Phase 2 was cancelled. January 8, 2026. The United States House of Representatives passed a spending package that effectively eliminated nearly all funding for the Mars Sample Return Program. The Senate confirmed the same bill on January 15. The Mars Sample Return Program office closed. Less than 4 months after Sean Duffy said we can't find another explanation. The cost had been a real problem. Estimates had ballooned to somewhere between $6.6 and $11 billion, far beyond original projections, driven by engineering challenges nobody had fully anticipated. The cost overruns were genuine. But the timing sits with you if you think about it long enough. Victoria Hamilton, chair of the Mars Exploration Program Analysis Group at the Southwest Research Institute, noted in a formal statement that Mars sample return had been ranked as the single top priority of the last two planetary science decadal surveys, the major reports prepared by the National Academies of Sciences every 10 years, representing the consensus of the entire global planetary science community. The number one priority, twice in a row. Cancelled 4 months after the strongest biosignature finding in Mars exploration history. "We are deeply concerned by the cancellation," Hamilton said. That is restrained language from someone watching something irreplaceable disappear. Morgan Cable, research scientist at NASA's Jet Propulsion Laboratory and co-deputy principal investigator of the PIXL instrument, had formally described Sapphire Canyon as the mission's best candidate for containing signs of ancient microbial life processes. The team that built the instrument, that spent 12 months vetting the evidence, that published it in Nature, their own assessment was that what they found might be the best evidence of ancient life ever collected. And the response from the funding body was to eliminate the program that would allow that evidence to be properly analyzed. That tube is still there, right now, in the rover, on Mars. China. In 2028, the China National Space Administration will launch 2 rockets as part of a mission called Tianwen-3. The plan: land on Mars, drill up to 2 meters into the Martian surface, collect approximately 500 grams of soil and rock, ascend from the surface, rendezvous with an orbiting return vehicle, and carry those samples back to Earth. Target delivery date, approximately 2031. China has already proven it can do the hard parts. Chang'e 5 and Chang'e 6 both returned lunar samples. Chang'e 6 specifically landed on the Moon's far side, the first mission in history to do so, and came back with material. The engineering lineage for sample return is established. If Tianwen-3 succeeds on schedule, China becomes the first nation in human history to return physical material from another planet, not a footnote. The first time in the history of life on Earth that matter from another world arrives here for study. Tianwen-3 will not be retrieving Perseverance's samples. It will collect its own from a different location, but the capability is identical, and Chinese laboratories will have access to the same kind of instruments powerful enough to analyze Mars material for biosignatures. If those samples contain their own evidence of ancient Martian life, the country that built the rover that found the first potential biosignature will be watching from the sidelines while another nation makes the announcement. Live Science ran a headline after the cancellation. It read, "NASA's Mars sample return is dead, leaving China to retrieve signs of life from the red planet, leaving China." The United States, through decades of investment and the most sophisticated planetary rover ever built, found what its own scientists described as the strongest sign of life ever discovered on another planet, then canceled the mission to retrieve it. And the country now positioned to bring Mars samples home and find out the truth is not the one that did the finding. Ashley Murphy, reflecting on the organic carbon findings from Bright Angel, said this: "The evidence indicates that billions of years ago, organics may have been more than just locally present and may have been more widely available in ancient lakes and rivers on Mars." The findings are not pointing at a single anomalous rock in one corner of one crater. They are pointing at a Mars that, in its ancient past, may have had the chemistry of life spread across its surface wherever water sat long enough. And all of that chemistry, every sealed tube, every sample, every piece of that story is stranded up there, waiting. Remember the sealed tube from the beginning. It makes more sense now, probably, and somehow less. Because now there is weight behind it. The crater that was a lake, the ancient river valley, the arrowhead-shaped rock with the spotted surface that stopped a team of scientists cold. The 12 months of trying to be wrong. Sean Duffy at the podium saying, "We can't find another explanation in front of cameras that broadcast it to millions of people who mostly moved on within 2 days." The Nature paper, "The Science Advances Confirmation." Nikki Fox saying it is a signature, a sort of leftover sign. 4 months of silence. A budget line. A congressional vote. The program office closing. China announcing its launch window. the tube is still there, sealed. In a rover that is still operational, still drawing power from its nuclear generator, still running on a planet that has not had liquid water on its surface for approximately 3 billion years. The sample named Sapphire Canyon, drilled on July 21, 2024, from a rock that sat in an ancient riverbed for 3 billion years before a machine built by humans came along, took a piece of it, sealed it in a clean metal tube, and waited for someone from the same species that built it to come and collect the answer. The question of whether life exists, or ever existed, beyond this planet has been asked by human beings for as long as human beings have been capable of asking questions. Every culture that ever looked up at the night sky, every philosopher, every scientist, every person who ever lay in the dark and wondered, all of it has been building toward the possibility of an answer. And right now, the best physical evidence humanity has ever gathered that might speak to that question is sitting in a metal tube the size of a cigar, 225 million kilometers away, in the belly of a rover with nowhere to send what it found. The story did not vanish because someone hid it. It vanished the way things vanish in an era of infinite information, replaced by the next thing, then the thing after that, the ordinary avalanche burying it under its own weight. And then the funding died in January, quietly, in a budget package, and by then the September announcement already felt like something from a previous chapter. That is how the most important rock in the solar system got left behind. Not with drama. Not with a conspiracy, just with noise and money and the ordinary machinery of governments deciding what matters and what does not. The sample is still up there, right now, waiting,